Hi all, myself Dhanalakshmi. I am working as an assistant professor at from National Engineering College, Tripoli department. Today we are going to learn the topic of oil circuit breaker. So the oil circuit breaker is a type of circuit breaker in which the insulating oil is used as the arc quenching medium to interrupt fault current safely. For the oil circuit breaker is used for three important functions. First one is insulation. It prevents leakage current between contact and earth. And second one is cooling purpose. It absorbs the heat generated by the arc. Third one is the arc punching. It decomposes the gases, mainly the hydrogen gas is produced to extinguish the arc. So this is the basic flow diagram of basic operating concept. For the fault occur, the contacts are opened under oil and the arc is struck between them. The heat of the arc evaporates the surrounding oil and is dissociated into a substantial volume of gases, hydrogen at high pressure. So the hydrogen gas occupies a volume is about 1,000 times that the oil decomposed. So the oil is therefore pushed away from the arc and is expanded hydrogen gas bubbles around the arc region. Firstly, the hydrogen gas has high heat conductivity and cool the arc, thus aiding the deionization of the medium between the contact. Secondly, the gas set up turbulation into the oil and forces it into the space between the contact. So, thus eliminating the arcing product from the arc box. So, this is the basic operating concept. So, working principle of oil circuit breaker. Under normal operating condition, the circuit breaker having two contacts. So, the circuit breaker contacts remain closed, uh, allowing current flow the system without interruption. A fault such as short circuit or overload occurs, a trip signal is sent to circuit breaker. The moving contact separates from the fixed contact due to heavy current. An electric iron is formed into the oil medium between the contacts. The heat generated by the arc causes the surrounding oil to decompose into gas. So it mainly hydrogen gas. So hydrogen gas has excellent cooling properties. So the hydrogen gas cools the arc and reduce the ionized particles and thereby increasing the dielectric strength between the contacts. As the dielectric strength increases, the arc is completely extinguished. Once the arc is extinguished, the current flow is interrupted and the faulty section of the system is safely isolated. So this is the type of circuit breaker. So there are two type of circuit breakers are there: bulk oil circuit breaker and minimum oil circuit breaker. So the bulk oil circuit breaker, which uses a large quantity of oil. The oil has to serve two purpose. First one is it extinguishes the arc during opening of the contact, and secondly, it insulates the current conducting parts from one another and from in the earth tank. Such a circuit breaker may be classified into two types: uh, plain break circuit breaker and arc control circuit breaker. So first one is plain. This is the bulk oil circuit breaker. So it involves the simple purpose of separating the contact under the oil in the tank. There is no special system for arc control other than the increase in the line caused by the separation of the contact. The arc extinguishes occurs when a certain critical gap between the contact is reached. The plain break oil circuit breaker is the earliest type from which all the circuit breakers have developed. So this is the earliest one. It has very simple in construction. It consists of fixed contact and moving contact. It enclosed in the strong weather tight earth tank containing oil up to a certain level. So this is the oil level. So the up to a certain level. And air cushion. This is the air cushion. So air cushion is above the oil level. So the air cushion provides this air cushion provides sufficient room to allow from the reception of the arc gases without generation of unsafe pressure in the dome of the circuit breaker. So under normal operating condition, the fixed contact and moving contact remain closed, and the breaker carries the normal current. When fault occurs, the moving contacts are pulled out by some protective system, and arc. This is the arc. The arc is struck, uh, which vaporize the oil mainly into hydrogen gas. The arc extinction is facilitated by the following purpose. And this is the hydrogen gas bubble. So the hydrogen gas bubble generated around uh, the arc cools the arc column and aids the deionization of the medium between the contacts. So the gas sets up turbulence in the oil and helps in eliminating the arcing product from the arc path. The arc will lengthen due to separating contact. The dielectric strength of the medium is increased. So some advantages are there. So it has a high dielectric strength of oil, provide insulation, produces hydrogen gases. It helps the arc quenching, and the oil pressure aids decomposition. And some disadvantages, there is no special control over the arc other than the increase in length by separating the moving contacts. So and these breakers have long and inconsistent arcing times. So it needs regular maintenance and a high cost, bulky, and it's very heavy. So this application using high voltage power system, so substation for switching operation, power transmission and distribution level. So these application the bulk oil circuit breaker is used. And second one is minimum oil circuit breaker. So in the bulk, some disadvantages are there in the bulk oil circuit breaker. So we move for a minimum oil circuit breaker. In the bulk oil circuit breaker discussed so far, the oil has to perform two functions. Firstly, it acts as arc quenching medium, and secondly, it insulates the live parts from the earth. It has been found that only a small percentage of oil is actually used for the arc extinction, while the major part is utilized for insulation purposes. For the reason, the quantity of oil in bulk oil circuit breaker reaches a very high system voltage increases. This is not only increase tank size and weight of the breaker, but it also increase the fire risk and maintenance problem. In fact, that only a small percentage, about 10% of the oil in the bulk oil circuit breaker is actually used for the arc extinction. We have one question. So it leads to question why a remainder of oil that is not immediately surrounding the device should not be omitted with the consequent saving in bulk, weight and firing risk. This leads to development in the minimum oil circuit breaker. So a minimum oil circuit breaker employs a solid material for insulation purpose and uses small quantity of oil which is just sufficient for arc extinction. So uh, it has two compartments separated. It has two compartments separated from each other, but both are filled with oil. This is the upper chamber. So the upper chamber is the circuit breaking. Upper chamber is the circuit breaking chamber, and the lower one is the this is the lower chamber. So the lower chamber is the supporting chamber. The two chambers are separated by the position, and the oil from one chamber is prevented from mixing with the other chamber. So this is the position. So this position is involved is prevented from mixing from top chamber and lower chamber. So firstly, the circuit breaking chamber requires a small volume of oil which is just enough the arc extinction. Secondly, the amount of oil to be replaced is reduced as the oil in the supporting chamber does not get contaminated by the arc. So this is the supporting chamber. So supporting chamber, it is filled with the oil which is physically separated from the oil in the circuit breaking compartment. The oil inside the supporting chamber and the annular space formed between the porcelain insulation and paper is employed for insulation purpose only. And second one is the circuit breaking chamber. So this circuit breaking chamber also porcelain enclosure mounted on the top of the supporting. This is the top of the supporting compartment. So it is filled with oil. It has the circuit breaking chamber consists of fixed contact and moving contact and also turbulator. The moving contact is this is hollow. This is hollow and includes a cylinder and moves down over a fixed position. And this is the top chamber. It's a metal chamber and it's mounted on the circuit breaking chamber. It provides expansion space for the oil in the circuit breaking component. So the top chamber is also provided with separated which prevent any loss of oil by centrifugal action caused by the circuit breaker operating during fault conditions. So this operation is same as that of bulk oil circuit breaker. When fault occurs, this is the operating mechanism. When fault occurs, the moving contact remain the moving contact pulled down by the stripping spring and arc is struck between earth is struck. The arc energy vaporizes the oil and it produces the gas under high pressure. The gas is hydrogen gas. This action constrains the oil to pass through the central hole in the moving contact and resulting forcing the oil through the respective uh, turbulator. The process of turbulation is orderly one, in which the section or core is successfully quenched by the effect of a separate stream of the oil moving across each section in turn and bearing away its gases. So some advantages are there. So it uses very less oil, so it reduces the cost. It's a compact space and a lightweight. There is a reduced risk of fire and it efficient arc punching. So require less maintenance. So some disadvantages. So it's more complex design. Due to smaller quantity of oil, the degree of carbonization is increased. So there is difficulty of removing gases from the contact space and time. So the dielectric strength of oil decreases rapidly due to high degree of ionization. So the application is used in medium and high voltage systems, protection of transformer and generator. It's suitable for a modern compact electrical system. Thank you.